everybody. Welcome, welcome. Wonderful LA weather we got here today, so glad we're dry. My name is Lucas. I'm on the investment team here at March Capital, and I'm thrilled to be introducing our moderator, Nikao for this session. Nikao leads partnerships at AWS, where he works with VCs and portfolio companies to help maximize the benefits of AWS services. Prior to AWS, he was a director at TikTok, where he led their US advertising sales team, and before that, he was a founder himself, having built and exited 2 companies in the advertising and media entertainment spaces. So he has seen it all, he has done it all. I don't think there's quite anybody better to be presenting this cohort of really exceptional founders building groundbreaking products with AI. So without further ado, Nikao.
Good afternoon, everyone. Hope you all are doing well. It's a rainy day outside, but I'm very grateful that you all are here inside spending time with us. And we have a wonderful showcase that we'd like to present to you today. It's going to be comprised of 6 of the most unique and interesting and cool startups that we have working with us at AWS. You're going to hear from founders that have built incredible businesses affecting industries such as media and entertainment, advertising, sports, retail, healthcare, life sciences. It's going to be an incredible show, and really grateful again that you guys can all be here. And they'll all be presenting their unique generative AI solutions and how they're impacting and affecting their customers. We first will lead up with Amit Jain, the CEO and founder of Luma AI, who is building an incredible video generative AI model. Amit, I'd love to welcome you to the stage. All right, there he is. The magic of generative AI, you get him live and in person.
Thanks.
Yeah.
Hey, everyone. It's great to be here. Today, I want to tell you a little bit about our work at Luma AI. So our mission is to build the multimodal general intelligence future, where models can understand, generate, and operate in our physical world. When we say multimodality, we imply models that are able to see in video, hear in audio, and reason in language, all in the same space. We believe that's what the future looks like. Currently, LLMs think in terms of text and understand text. This caps their performance for pretty much anything that has to do with the real world. Text alone is not enough to reach AGI. So we are starting by building multimodal models that are capable of generating production-quality videos for premium production across entertainment and ads. These models, I'll show you a demo of it, is able to reach a level of quality that videos you're going to see, you're not going to be able to tell if it came from generative AI or models like that. So our first one is called Ray 2. And let me just actually have you watch some things generated from Ray 2. These are footage created by our users, not cherry-picked by us. The video and audio is both generated from our model.
Let's suppose that you were able every night to dream any dream you wanted to dream.
That's Ray 2, our latest model that we launched in January. It's the only model on the market that is able to do 4K video at 60 FPS in 10-bit color. It generates 5 seconds to minute-long footage, and I don't know what happened there. But it's fast, controllable, and extremely photorealistic. If you look across the board of other models in our space, Ray 2 produces this very high-quality, high-dynamic footage. And if you look across the board of OpenAI Sora and some of the Chinese models, this is the sort of results you get. This is a comparison not created by us or our team. This is just from one of our users on Twitter. You can find this on Twitter, actually. The big difference is in how fluid and smooth the model is and how realistic the footage actually looks like. The physics, the animation, the keeping track of particles of water, all these kind of things. We built Ray 2 over the last year by scaling this video model backbone to video plus audio plus text and putting in 10 times more compute and 17 times more data than any video model that has come before it, including OpenAI Sora. It leads to this scaling behavior where we see fast, natural, coherent motion and simulation-accurate physics. Just as one metric of performance between OpenAI and Luma, we are able to reach about 85% preference over that model which came out about basically the same time as us. More demos of how our model actually performs. So you're able to see instruction following, physics, the visual effects, simulation accuracy, photorealism. It hits basically the highest marks today of any model that is on the market. I mostly got videos to show you because that's what we do. Here's some more. Light reflections, being able to have really fast dynamic motion like this. This is generated from just text prompts at this point. Cinematic shots, VFX, surrealism, and finally, control. Ray 2 is a very, very, very strong foundation model, but it's useless without control, where you are able to ask the model to do what you exactly want from it. So our customers who are creating TV shows, movies, and ads want to have their own content inside the model, want the model to do exactly what the director wants to do. So we are building some of the most advanced controls of any model that is available on the market. Ray 2 allows you to prompt it with text, detailed prompts that can go for pages long, allows you to give it images as prompts, and allows you to give videos as prompts. So video that has been shot on camera can be used as a prompt to edit and then change that video with Ray 2. Ray 2 is also able to generate audio, as you saw an example of that. And if you go to our Twitter, you can actually see many, many examples of that. It can take in keyframes. So you have a timeline. You can give Ray 2 many, many images in the middle, and it will generate video that actually traverses through those keyframes. And it is used actually heavily by studio partners already. And it has, I think the formatting is very annoying to me, but it has one of the best object consistencies of any visual model, not just in image space or video space. So imagine you're Nike, and you have a shoe that you're creating an ad for. Ray 2 can take video and images of that shoe and then produce ads for it without modifying that thing or degrading it, things of that nature. So before I end, I'm going to show you a feature that we are launching today. This just launched a couple of hours ago. This is keyframes that we're launching now to public from our studio products. So let me tell you what you actually saw. There was a start frame, and there's an end frame that the user gave the model. And then you actually have the whole video coming out of it. Our goal is to replace production. Our goal is to basically make the model the source of truth for all the footage that you and I will see in very, very near future. We are a horizontal AI company. We are building infrastructure for multimodal AI. Our services are available as a self-serve product called Dream Machine, which is actually heavily used by professionals today who are making video for studios, for themselves, for YouTube, everything up and down the chain. In addition to that, we have an API over which all our models are available and used by our enterprise customers to integrate into their own workflows. Our models are also available over Amazon Bedrock, which gives you a very scalable and safe environment where your data does not leave your VPC on Amazon. So these models are available today here, and we are expanding our distribution as time goes on. Thank you for having me here. It was great to be.
Great job. Thank you so much, Amit. What an incredible presentation. Isn't it so amazing how you saw the output fidelity and the physics of the videos that Amit was able to share with us today? It's also worth noting that Luma Labs and Amit were part of the 2024, our first ever AWS Generative AI Film Festival. You can look it up. We received coverage from Wired Magazine, Fortune, and we had the good pleasure of working very closely with Luma and a number of fantastic AWS startups focused on the generative AI space across media and entertainment. Now we're going to switch from media and entertainment to hear from two incredible founders. The first one who is solving for medicinal chemistry by applying machine learning to the data sets that they've been analyzing. His name is Ian Quigley. He is the CEO and founder of Leash Bio. Very excited to have Ian come on up. Ian? Big round of applause for Ian. Thank you, sir.
There we go. Okay. There we go. Can we hear me? Yeah? Okay. Hey, thanks for letting me come on stage here and tell you about what we're trying to do over at Leash. We are an artificial intelligence drug discovery company. And at our very highest level, I do want to talk about what is a drug. It is a small molecule that sticks to a protein in your body that might be misbehaving. And we want to be able to predict these. We want to be able to take the structure of a protein, which is encoded by those amino acid layers on the left, a chemical structure of some kind, and then make a good prediction as the likelihood of them binding together computationally. Otherwise, we've got to do these huge brute force searches across chemical space to find new therapies. And when we think about trying to solve this problem at Leash, we are informed by the history of machine learning solving other difficult problems. And I put them on the slide here. Here's a bunch of them. Some people in this room may have worked on these. One thing that we've noticed is a very steady trajectory where there is the math that was invented that solves the problem. On the timeline, that's where those triangles are. And then some time goes by where the problem keeps not being solved. A great example here is convolutional neural nets, which were made in the 80s, are credited with identifying objects in pictures. But in the 80s, you couldn't type horse in your phone and get all your horse pictures. It took well into the teens, and that was the result of a big data set, a collection of pictures of horses in mailboxes and airplanes. It's called ImageNet. It's very famous. And once that data set was created, then the problem was solved. We have seen this over and over again with Go, chess, language translation, Jeopardy, all sorts of very challenging problems. Really what cracks the problem is the generation of a new data set that's the right distribution to create a bias, all these wonderful characteristics. We've done this in the life sciences too. You guys may have heard that we're pretty good at folding proteins now from amino acid sequences. I won the Nobel Prize in medicine a couple months ago. There's a lot of protein folding companies that are now in existence trying to make protein-based therapies. It's fantastic. But a lot of that, we feel, has been built by this data set that was collected by many researchers for many years of crystal structures and just raw sequences. This enormous corpus of data allowed the models to learn these structures and fold them appropriately. We don't really see that with small molecules. Chemicals are different than these proteins. We don't really are very good at predicting their interactions at all. We want to be able to predict them. And so we ask, does the data set exist to solve this problem? And we really don't think so. When we look at the number of small molecule to protein interactions that have been measured that are publicly available, it's about 400,000. It's a collection called binding DB. This is after you deduplicate it. And relative to the amount of data that you would want to train even a middling chat model like a GPT-3, it's 1 million times less data. It's just not there. At this point, when I talk about this problem, someone in the audience usually pipes up and says, well, don't existing pharmaceutical companies have much larger data sets? And they do. but they're typically not collected with machine learning in mind. They're collected to go off to solve a very particular problem, and they don't have the coverage, certain controls, sort of metadata collection, all these other things that would really make the models sing. It's quite challenging, and what you really need to do is to collect it from the beginning with a very uptight experimental design. And it's going to require a fair amount of forward-thinking, long-term planning, like a big capital investment, which is why we made the first 12 billion physical measurements at Leash in a lab I built in the basement of my house. These are actual pictures from the lab. We put a genome sequencer down there, and you can see that my dog was there. It did not cause any real problems. If there are chemical people in the audience, if you just Google Leash and Belka, you'll see the first 4 billion measurements that we released to the public for folks to train their own models on and evaluate the quality of our data. We're not in the basement anymore. We're scaled up quite a bit. So the team went from 4 to 11, but in that team of 11, we've screened 350 proteins across 6 million molecules each in the past couple of months. We should get to 800 by sometime in Q2. We do all the protein production in-house, all the automation in-house, all the screening, all the sequencing, and all the downstream machine learning approaches. We don't think it's an exaggeration to say that we're screening more protein targets right now than any other shop on Earth. And what we're going to do with all of this data that we're producing is use it to find novel therapeutics and be able to predict small molecules binding to protein targets in a way that will accelerate drug discovery. So we make all these measurements, train language models on these measurements, use them to more efficiently explore chemical space, and then to jumpstart therapeutics programs. And we just got our first mouse data back on Friday, and it's doing the kind of things that we wanted to do, and we're quite excited about that. We are an investor conference. I would be remiss if I didn't say that we just launched our A couple weeks ago. So if anyone here is interested in talking to me about that or the science that we're doing, I'm very happy to. And I want to thank all of you for your attention and AWS for hosting us here.
Thank you so much, Ian. What a wonderful presentation. 12 billion. 12 billion, folks. That's the number of data points and sets that they analyzed in his basement. So just imagine what he's going to do in his new facility and the new round that he raised. Incredible innovation is going on with Leash Bio. It's also worth mentioning that Leash Bio was a member of our 2024 Generative AI Accelerator here at AWS. And following Ian at Leash is another member of that cohort, the co-founder and CEO of Noetik, Ron Alfa. Ron, let's welcome him to the stage with applause.
Thank you all for the opportunity to present. So my name is Ron. I'm CEO, co-founder of Noetik. And our mission is to discover the next generation of cancer therapeutics using generative AI. So Noetik's thesis is simple. Clinical translation is the most important and problematic part of drug discovery. This is where most drugs fail, and where if we can make an impact, we can make the biggest difference for patients. The challenge is biology is incredibly complex. So we try to simplify that complexity. We try to develop models in a dish, models in animals, and really try to figure out how can we get a drug from early research to patients with some predictive power. At Noetik, we think that the best model for patient biology is ultimately the patient. And so what we've been asking is, can we train generative models on patient data so that those models can help us choose the best drug for each patient population? So fundamentally, what we're doing are building foundation models that can learn from raw patient data. So these models are taking in human tumor data, learning the biological relationships, and once they're trained, they become incredibly powerful. We can use them for drug discovery tasks, we can use them for biomarkers, we can use them for diagnostics, and really they become very broadly applicable across the field of oncology biology. As an AI company, it's important to focus on the data as the first core asset of the company. In our labs, we are generating thousands of tumor representations from human patient samples. So these data don't exist for these models in the public domain. we have had to source human tumor samples and develop processes to translate those tumor specimens into a fit-for-purpose data set for machine learning. And so what that means is we are thinking about all the different types of data that the models are going to need to see in order to learn human tumor biology. These are actual images of some of our data from a single patient sample. And what you're seeing is several different image layers that provide different biological information. So in our labs, what we're doing is profiling these human tumors from the level of the tissue with what the pathologist would see in the hospital, all the way to cell biology and proteins, and then down to the molecular layer with RNA and DNA. To date, we have generated thousands of these tumor representations, beginning in lung cancer, but quickly expanding pan-cancer, starting to profile tumors such as sarcomas, ovarian cancers, breast cancers, and others. And what's really unique about this approach is we can now use these data to train multimodal models. So these are transformers, which are similar to LLMs, as I'm sure you're all aware of. But the difference between our models and LLMs is our models are operating on images. Now, we use some of the same principles to train these models on biology that you would use to train an LLM, in that what we are providing the model is a task that we force it to reconstruct missing pieces of data. So essentially, we provide the model with images, and the model has to learn to reconstruct parts of those images from masked data. Over time in training, the model begins to learn the biological relationships across this biological information, and essentially becomes a foundation model for tumor biology. The other aspect that's unique here is, if you were to pull some of these types of data sources from public domain, you wouldn't have essentially paired data. For every patient and every sample, we have every one of these layers. And so that means when the model is learning about the biology and looking at, let's say a tumor cell, for that exact tumor cell, it has the tissue architecture, the RNA, and the DNA. And so it can really begin to learn the relationships. So here's just a quick demo of how this works. So here I'm showing you basically a visual prompt, and we've asked the model to be able to reconstruct a ground truth image, and this is a protein image from this highly masked image data. And you can see from the visual prompt, it's nearly impossible for us as humans to figure out that masked data is going to correspond to the ground truth image. But the model, over an extensive amount of training with a large enough amount of data, can actually begin to solve this problem and can reconstruct the image quite nicely, which is what you see in the middle. Now, this is a very simple task, and it much like the task of next word prediction with LLMs, it's hard to appreciate that this scales, but in fact it does scale to much more complicated approaches. So one of the recent technical reports that we put out is this virtual cell model, and here we can basically take a cell of interest and we can transport it into a tumor and run a simulation. And so essentially what we're asking the model to do is, if I put an immune cell in some patient sample, what happens to gene expression in that immune cell? And we can run these simulations across many, many patient samples and essentially begin to build a data set where we can make inferences around changes to drug targets and biomarkers in the raw patient data itself. So if you begin to put all this together at scale, you can run these simulations in individual patient samples, but you can also begin to scale them across cohorts of patients in the data. What begins to emerge is a system that allows you to solve this fundamental problem. So this is actually real data. What you're seeing here is an embedding space of representations of hundreds of patients, and the model can begin to predict which patients would respond to a particular therapeutic. And in this case, this is an immune therapy, and the model does quite well at identifying subsets of patients that are responders in the clinic, and importantly, who is not a responder in that clinical trial. So I see them at time. I'll kind of get to the end here. We're Noetik, so we're a Series A company. We've raised in total about $60 million to date. We've been around for about 2 years and quickly progressing through milestones. Would be excited to talk to folks here that are Series B investors and start to think about, planning for our next fundraise, which, we're not immediately fundraising today, but planning for the next 12 to 18 months. Thank you very much for your time, and great to meet you.
Awesome. Thanks, Ron. Thank you so much, Ron. What an incredible presentation. And the last two founders have been talking about how they can apply artificial intelligence to optimize for patient healthcare outcomes. That's a very virtuous and admirable goal, that mission that they're focused on. Here at AWS, our focus, like with these other founders, number one is customer obsession. And through customer obsession, we're able to earn trust and deliver results. And one of the hallmarks of delighting your customers in our everyday interaction with other partners, with other companies, is voice. This next founder that I'll welcome to stage is pioneering artificial intelligence as it relates to speech to text, speech to speech, and text to speech. He has an incredible background as a particle physicist turned founder entrepreneur. I'd like to welcome to the stage, and a big round of applause for Scott Stephenson, the CEO and founder of Deepgram.
Hello, folks. So I do have some slides, and I'll go through them, but I also just got a note from one of our team members today saying we have some great voices that you could demonstrate. So I'm going to jump into that, and actually the AV people have no idea I'm going to do this, so if it doesn't work, I'll just quit and we'll go to the slides. But let me just play a voice here.
Hello. One moment. I'm working on it. Please hold while I pull up your account information. This won't take long. I'm checking this for you. Give me a moment to pull up the information. Your amoxicillin 500 milligram tabs.
Okay, so I just wanted to give you an idea. This is like a human-like voice, and it's just reading off a script, right? But I also have another demo that I'm going to attempt to do. This one really, we don't know if it's going to work or not, but just a second. Hello.
Hi there.
I'm on stage right now, and I'm really at a loss for words for something funny to say. What should I say?
Prize setting. Why did the Scarecrow win an award? Because he was outstanding in his field.
Because he was, so sorry about that, but because he's outstanding in his field. But so what we do at Deepgram is we build a voice AI platform for enterprise use cases where many companies build on top of Deepgram, and they use our API in order to power voice experiences. So they'll power quick serve restaurant, fast food ordering. They'll power like call center, hey, what hours are you open? Or can you look up my tracking number for me, and that type of thing. But actually, we're a horizontal company, and you could use Deepgram to do anything. You could use it to do streaming, captioning on videos for a video website. You could use it for lots of things. And as Nikao mentioned, we do speech to text, we do text to speech, and we do speech to speech. And I'll give you an idea of how large this market is. I would estimate in near term it's going to be a $100 billion market. And the idea here is that yes, that this market now, I would say, is somewhere around 20 to 30 billion. And you say, well, in like 3 years or 4 years, how is it going to be a $100 billion market? Well, you're talking about a labor disruption that's happening. So the labor market in the world is a $50 trillion market. And a significant portion of that is call centers, people taking orders, that type of thing. Fairly low-hanging fruit that will be augmented by this type of technology in the very near future. And so you'll see this across call centers, drive-throughs, legacy IVR replacements. Press 1 for this or 2 for that, or speak sales or whatever in order to get to sales. All that's going to be replaced by agents in real time. And I just wanted to quickly show like how our business works. So Deepgram has been around for 9 years. We build the models in-house at Deepgram. But one of the most important differentiators for us and moats that we have is the Deepgram platform. So it hosts our speech-to-text, our text-to-speech, our speech-to-speech. But really, when you're an enterprise customer, you need to trust that this platform is going to work, that it's going to have low latency, that it's going to scale up, that it will operate in your VPC if you need, that it will that the cloud will be there as a backup. These are all things that I think a lot of folks don't talk about in AI quite yet, because AI is mostly been turn-based and sort of ChatGPT, like most people are familiar with that type of use case. But business use cases are going to be real-time AI with all of the enterprise, enterprises need low latency, high throughput, reliability, and I'll go through this in another slide, but with all of the accoutrements that enterprises are going to need. And so what we do is we work with tech ISVs, so folks who build software that you buy, and then under the hood might be Deepgram powering that interaction. Or we work with partners like AWS or others in order to power in their platform, in order to add voice to their capability so that you can now power your own voice interactions through that platform. And then we'll also sell direct to enterprises as well. This platform is extremely important. You need low latency, you need high throughput, you need to be able to adapt the models to the use case. And so we provide this in the platform. And I like to look at this as basically entertainment versus enterprise. And so there are a lot of entertaining things. There's a huge market of entertainment that is about to be addressed. So like Luma was just on stage, they're addressing that market and serving that market. For Deepgram, we do more low-hanging fruit, massive scale use cases where you're generating tons of human conversation. So here are some quotes that give you an idea of some of our customers. A top 10 retailer saying, everybody knows perception and cost are the hard parts, and that's why they use Deepgram. Voice is different than text. We work with the top LLM providers in order to, not all of them, but many of them, in order to provide their audio capability. They don't say that it's Deepgram under the hood, but nevertheless, that's how a lot of it works. And you can see the quote from the health tech provider there. And I just wanted to talk about the future just briefly in this last minute. The way that most of these systems work right now is, and that demonstration that I did early on that was only mildly successful, also works in this way that's at the top of this slide, where there's a single point, and that single point, you can't read it, but it says hello. And this is what happens when you speak into a microphone, you use a speech-to-text system, and then it takes that rich audio signal and then flattens it down just to text. So like if you speak the word hello, well, you could be speaking it with rain in the background, you could be speaking it with an accent, you could be speaking it, you're young, old, excited, not. There are all sorts of rich information in there, but it gets flattened down to the single word hello. And so you can imagine if you have an entire sentence or paragraph or whatever that you want to say, all of the context is missing from that, or not all of it, a huge portion is missing. And so if you want speech-to-speech to work really, really well, you need the context, and that's what this lower plot here is representing. It's all the different voices. Are you saying it in an angry way, a curious way, but just a single word? And this is how the future of speech-to-speech is going to work. These are the models that we're building in Deepgram. We actually just released Neuroplex, or we did the announcement for Neuroplex, which combines all of this into a single model. But importantly, it's controllable, it's explainable, and so for an enterprise use case, you can actually understand why the bot is making the decisions that it's making, and then from that, control the way that it behaves, and doing it all with low latency, high throughput, and good COGS. And so this is what we do at Deepgram. I know it was just a quick presentation, but if you have any questions, just ask me, find me after. Thanks.
Thank you so much, Scott. That was awesome. So as you can see, the future of delighting our customers, working closely to acquire and grow these customer relationships, is heavily predicated on voice, on speech to text, text to speech, and speech to speech. Again, the goal is to deliver outcomes for our customers. And next, I'd like to welcome to stage an incredible founder. She's built and sold multiple companies, and now her latest startup is applying artificial intelligence to, again, delight the customer through the optimization of the customer purchase lifecycle journey for retail. Stephanie, CEO and founder of Vody, welcome to the stage.
Hi, I'm Stephanie Horbaczewski, founder and CEO of Vody. We build multimodal large language models for retail companies. So you have all heard that expression that a system can only be as good as the data going into it. Generative AI has completely transformed what is possible at that data layer, and that's exactly where Vody sits, enriching product catalogs with more customer-centric data. I'll give you an example from Nike. People looking for a Taylor Swift jersey expect to find a Travis Kelce jersey. This is not your standard product attribute data, but it is how customers think about products. I bring my experience as a second-time founder with a 9-figure exit. I grew that company to over $100 million a year in revenue and discovered there was a much bigger problem to solve. My retail customers were struggling to get unstructured data into machine learning applications. So in 2019, I founded a research lab and started working on this problem. I'm incredibly fortunate today to be joined by a formerly Etsy team with a lot of experience building these kinds of systems at the type of scale that enterprise needs. I think the most important thing to cover right now is that the ROI is stunning. We are expecting 9-figure returns from our initial deployments. We approach this data as a buyer engagement pyramid. So think about the first layer as table stakes. We had one customer trying to sell the piece that you screw a fan into with nothing more than the title and the image. This is what buyers need to fill their product data. If you have a taxonomy, we can fill it. Level 2 gets into bridging that semantic gap between what a manufacturer provides and how a customer actually talks about a product. Once you understand all of this, you can get to level 3. You can look at drawing connections between your products, the utility, behavioral attributes, and including all of them. And level 4 is the holy grail. This is explainable AI and personalization. We've all experienced a lot of this at Netflix. I, for example, did not realize that I liked stories about siblings until they renamed my carousel that way. This data layer allows you to give those wow moments in personalization. Today, I'm going to focus on giving you some examples from levels 2 and level 4. Unstructured data examples. So this is the different lenses that customers take with products. What activities they might use it for, like hiking in Yosemite. Who they might gift it to. One of our favorite use cases is generating the possible search queries for a product. So the more specific the search query, the higher the intent to purchase. If you're very specific, we see up to 5x conversion rates. Let's use an example. A black women's lug sole boot with removable embellishment. There is an enormous opportunity to take those search queries and build landing pages on Google. I invite you to go to Google and see what an enormous opportunity that this is for brands right now. Sorry, I was supposed to shift to the next slide. Explainable AI and personalization. So this is the idea that for every product, there are many buyers. It is taking a polo shirt and marketing it to a young professional by saying that it's incredibly versatile and goes from work to weekend, and marketing to an athlete by saying that it is sweat wicking. You can do this on the reverse side with buyers. You can take what you do know about a buyer and generate a profile about them. So you can personalize the homepage of an app, for example. This person likes elevated basics and neutrals. That's what they should see when they log into your product. Let's talk a little bit about what it takes technically to do this work. There are 3 main components. The first is building a fine-tuning data set. So we are indexing the top e-commerce sites every single day and building a fine-tuning data set of customer language, trends, et cetera. This allows us to quickly fine-tune the latest and greatest models. Right now, we happen to really like Qwen and Claude, and turn around what is the best solution for each one of these applications. Number 2 is that most of these models are very large. They are very expensive. They are slow. So we have invested deeply in quantization and distillation techniques so that we can make this stuff very affordable and scale to the size of enterprises at billions of products. And the last piece is by far the most complicated. It's the ML orchestration. This is an entire ensemble of models to deliver these solutions, doing continuous quality monitoring, security, and we are delivering all of that via a seamless API. Thank you to our deep relationship with cloud, in particular AWS. We can say that Pilot is completely sponsored by them, and they have done work like the GenAI competency to provide procurement for our enterprise customers. So I will leave you with this if you know any retail customers. What we are pitching is that we are guaranteeing revenue growth in 6 weeks at no charge to you. I will end on that high note. Thank you so much to Nikao, AWS, and Montgomery Summit for having me here today.
Fantastic. Thank you so much, Stephanie. It's incredible to see the application of AI as well to retail, right? To optimize the customer journey, to ensure that the products, the solutions, the services that they're looking for and shopping for are properly served up. So finally, our sixth and final presenter, an incredible founder, is revolutionizing the audio space. She's applying deep learning to separate and discern and identify from any type of audio sound, music, effects, and dialogue. I'd love to welcome to stage the winner of our 2024 Generative AI Accelerator Unicorn Pitch Tank event at reInvent last quarter, Jessica Powell, CEO and founder of AudioShake. Big round of applause for Jessica.
Hi. So you may never have thought about it before, but both humans and AI have hearing problems. We as humans do really well in noisy real-world environments, right? We don't like it, but we can understand each other when we're yelling at each other in a bar. And we can understand the different nuances of human communication. Machines do terrible in those kinds of tasks. Machines, on the other hand, are really good at detecting anomalies, patterns. They can filter and edit sound. They can hear frequencies that we can't hear. So what if you could make it that AI could have human superpowers and humans could have what AI can do? And that's what we do at AudioShake. We make sound usable for both humans and machines. We've seen an extraordinary amount of growth over the past 6 months. And I'll get into that a little bit why later. But let me first explain why sound is really hard for machines. So this is a spectrogram. This is essentially an image of an audio file. And on the y-axis, we have frequency, and on the x-axis, we have time. And if you're a machine, this is all you see. You don't know, is this a movie? Is this a piece of music? Is it people talking? And that's where AudioShake comes in. We can detect and isolate this sound so that then it can be used in all kinds of different workflows. We're essentially core audio infrastructure. So we can take something that sounds like this. And just extract what's needed.
And liftoff of the Space Shuttle Discovery returning to the space station.
So we work across a broad range of entertainment and speech workflows. So in film, movies, TV, and sports, we do things like separate audio for sync licensing, remixing, localization, immersive audio, and even copyright compliance. On the machine side of things, we're used, for example, in ASR captioning workflows to isolate speech, like you just saw, before it goes through ASR. We also do a lot of work in metadata extraction and post-generation editing for all kinds of different voice and generative AI workflows. And we do this all with one model architecture that allows us to scale to all kinds of different uses and different sounds. Our customers use our on-demand platform, our APIs, streaming-capable SDKs. And let me show you how this all works in practice.
It's like a dream come true, isn't it, really? We talked about nerves and coming into a game like this, just the magnitude of this game, massive game. Was there a hangover at all from last season, the result, and the coming to us?
Couldn't be more mistaken. We're here to help you.
By deactivating them.
Absolut, ja. Dort hat sich was eingenistet, Noah.
Well, you know how in a typical podcast,
all the voices and sounds get kind of mushed together into one track.
One big audio stew.
Exactly. But imagine if we could like separate out all those individual voices.
I think that you should get an airport. No, I think that you should get to an airport like 30 minutes before boarding maximum. I want to walk right through security.
You enjoy the lounge. That's why it's called a lounge.
Guys. So we work with some of the world's biggest media, entertainment, sports, and tech companies. That ranges from music labels, film studios, sports leagues, and big tech. We have state-of-the-art, patented, proprietary models, and we have really unique data partnerships with some of our customers that feed into all of our models so that all of our customers can benefit. We also have a deeply technical team with over 60% of the team having PhDs in AI or electrical engineering. I'm a former VP at Google, and my co-founder Luke used to lead data science at Plaid. We're also all musicians and huge audiophiles, and so we get super excited about the idea of what you can do when you can open up audio and make it easier and more accessible for both humans and machines, for creative workflows, productivity, and monetization. And we've experienced over 600% year-on-year growth with 100% enterprise retention. So if you're really excited about audio or know companies that are wanting to open up audio to make it for creative use or monetization or accessibility, or sure, you eventually want to invest in a company that does this, please come talk to me. Thanks.
Thank you so much, Jessica. That was an incredible presentation. I got chills when I saw the opera singers, Pavarotti, Bocelli. It was incredible. The way the technology works to discern and separate out the different nuances, the stems, if you will, from audio. Well, thank you all so much for joining us. Another big round of applause, not only to our founders, but also to the March Capital and Montgomery Summit team for putting this all together and for making this happen. Thank you all for coming. Enjoy the rest of your conference.